Today is May 21st, 2025. I present to you AquaSentinel. This is our IMCS PCIT combination project, and I will give you an overview of our whole project. So at first, let's come to the network diagram we have. This is our network architecture. On the left side, this is our IT network, and on the right side, this is our OT network. Both our IT network and OT network, they are connected with two different firewalls, and they are Fortinet firewalls. So on the IT network, we have three zones. One is the DMZ zone, another one is the domain controller, the business and enterprise zone, and the other one is the whole OT zone. On the DMZ zone, we have the FTP server, DNS server, and corpse website, one IDS honeypot, and the ADDS controller, the domain controller, and other clients. I will walk you through the whole plant right now, where you will see where each of them are connected. So for the DMZ zone, this is our web server. This is running a web portal where AquaSentinel's employees log in order to go to their projects or their daily works. Then this is our domain controller, our ADDS server, which is mainly used for authorization and authentication. After that, we have here our Debian Linux server, which is running the FTP server for file sharing. If you come over here, we are running Raspberry Pi, which is running the DNS server, and it is currently running a Pi-hole. This on the left side, the FortiGate firewall we have. This is our IT firewall. On the right side, the firewall we have. This is our OT firewall. Now I will walk you through the OT network architecture. For OT network, we have one honeypot on the DMZ and remote access device on the DMZ. On the control zone, we have the engineering station and the HMI. On the field device zone, we have the remote I/O and the PLC with Ethernet IP card. So if you see here, we are using an Allen Bradley PLC in order to control our level tank. We are using a Seymour HMI in order to control the level of the tank and put set point, gain, then integral and derivative. This is our ladder logic for the whole plant. Now I will tell you what the plant is doing. Our plant is maintaining a certain level on the level tank, and it has two pumps. One is inlet pump, one is outlet pump. Our inlet pump is connected to the remote I/O, and our transmitter is also connected to the remote I/O. We have another separate PLC here running on, which is mainly used for alarm. So when this proximity sensor crosses the certain threshold, the alarm gets activated and it says that the tank is overflowing. And for the honeypot we are using on the DMZ zone, this is basically we are running a corn pot here, and it's also getting hot on a Raspberry Pi.
So basically you have two honeypots, one DNS, one honeypot.
One on the IT zone and one on the OT zone. For the IT zone and OT zone, they both are separately connected to the internet. We have different domains for our IT zone, for OT zone. The IT zone domain is aquasentinel.com, and the OT zone domain is ics.aquasentinel.com. Now, as I have given you the whole overview of the plant, how we connected everything and our network architecture, now our main goal is to attack the plant and mess up with the level 10. Now my teammate Deval will take you to the attack scenario.
So hello everyone, my name is Deval, and today we will be performing the attack on this AquaSentinel organization. As you can see, they are running an FTP server which is connected to the internet. So what I'll try to do, I'll hijack this FTP server, and from this FTP server I should have access to the domain controller. Once I have access to the domain controller, since the domain controller is used for all authorization, authentication and accounting, I'll be using whatever materials I can find from here to hijack their OT plant. My ultimate motive is to overflow their tank and shut down their plant so they can't do anything. So let's move on, see what we can do. Hello everyone. Our story will start from the login page of AquaSentinel. Now, on their login portal, I discovered something interesting. When I entered a command to display the databases, yep, I could see all the databases which are present in this organization. Okay, let's see if we can find out all the users which are currently present in this organization's database. And yeah, I can see all the users in the database. Okay, that's admin, Saeed, Deval, and Sunil. All right. Now, if this organization is making such rookie mistakes in their web page, I wonder how their organization is running. So through NS lookup, I have already found out the IP address that this web server is running at. It turns out to be a BCIT public IP. Okay, let's nmap. Let's see what services are running on this thing. All right. We have an open FTP port, open VNC port, and yeah, that's the web page. And now let's dig a little deeper to find out the exact version of the service that's running on this. Okay. Service version P4 for it to be a little fast. And okay. Since we are using the dash A flag, this guy might take a little time to actually display anything. But hopefully it shouldn't take super long. Okay, 3 seconds remaining. Okay. Let's scroll up. And okay, it's running VSFTPD 234. Ironically, this stands for Very Secure FTP Daemon. Now, this is an outdated FTP version. It has a little vulnerability. Whenever you pass a username with a smiley face at the end of it, it gives you backdoor access on port 6200. Let's see if we can exploit this FTP vulnerability. That's the 443. Okay, they're running a Python web page here. And VNC. Okay, it's clear. Okay, let's try to connect through FTP. Okay, let's pass a username, say Henry, with a smiley face at the end of it. Okay, any password really doesn't matter. Okay, the terminal hangs. Let's see if there is anything on port 6200. Let's listen using netcat. Okay, let's try typing a command. Say, okay, let's try the who am I command and root. Okay, I am inside the server now. Let's see if we can do something else. Okay, since I can execute this ls root, I do have high enough privileges to perform some actual damage. Now, for demonstration purposes, I think VNC will be better since I don't have a shell here anyway. But we don't know the VNC's password. No issues. Let's just change the VNC password. Okay, I'm just gonna call it server super secure. And okay, no. Okay, now let's try another tool here. I'm gonna use a tool called Remina, which lets you connect through various remote login protocols, in this case VNC. Let's run Remina. Okay, let's specify the IP address along with the port number. Okay, the password should be server. And I'm in. So, okay, Debian background. So now I have access to their FTP server. Now let's see if we can find something interesting here. Okay. Uh, okay, let's check this guy's documents. Okay, tank HMI, what's that? Oh, PNG. Let's see what it is. All right, so this looks like an HMI graphic, looks like a process control loop. Now, why would a PNG like this be on a FTP server? There is a high chance that this FTP server is connected to an operational technology unit. That would make sense since AquaSentinel is a water refinery. Okay, let's see what else we can find here. Okay. Okay, that's the private IP, but if you can recall, we supplied the public IP. So I think this guy is actually behind a public facing router or say a public facing firewall. Okay, that's the broadcast. All right. Now let's check the logs on this guy. Okay, let's check the FTP logs. Yeah, FTP log. All right, a lot of IPs in this guy's subnet. Let's see if we can find something interesting. Okay, that's a different subnet, 120.2. First and foremost, let's see if we can reach this IP address. Okay, we can. So since we can ping this, let's perform some further enumeration and nmap this subnet. To see what other devices are lying inside this subnet. Okay, the nmap is done. Let's scroll a little up, see what we have discovered. All right. So we have port 53 for DNS, WSD API, LDAP, looks like a Windows domain controller. Yeah, MSRPC, yep, WSD API, another Windows machine, same here. Okay, so since it's a domain controller, I'm gonna exploit the Windows Remote Management Service through Evil WinRM tool. I'm gonna use the credentials that I found through SQL injection here. I'm gonna use the Said user with the password to see if we can exploit the Windows Remote Management Service on this domain controller. Ah, shoot, we got an error. What kind of error is it? It's an authorization error, so this user doesn't have the authorization. No worries, let's try this Deval user with this user's password to see if we can get in. Actually, let's just clear this out first. Let's apply the user and the password. And okay, we are inside the domain controller as this Deval user. Now, even though we do have access to the DC, this user still doesn't have enough privileges to perform some actual damage. So we need to perform privilege escalation. We need to become the administrator user. So what I'm gonna do now is I'm gonna run a Python script here, which is developed by Impacket. And what it's gonna do, it's going to discover the hashed passwords of the users in this Active Directory environment. Okay, I'm gonna run it in a virtual environment. So the script is in packet secret stump. What it's gonna do. It's gonna use the SMB client in the background, and it's gonna discover the hashed or encrypted password of all the users which are inside this domain at the moment. Now it's a little slow, but hopefully shouldn't take too long. Okay, it's working. Okay, we did get something. Let's let it run its course. Now let's scroll up to see what we have discovered. I'm sorry, this is slow because it's kind of like a nested remote connection thingy. Okay, let's scroll up. Okay, so we do have hashes. So as you can see, this double A3B thingy is same for administrator, guest, and default account. Now this signifies that it's the NTLM hash and this 86 thingy for admin. This is the actual hashed password. I'm just gonna copy it here. Now let's go back to our tool and I'm gonna supply this hash to see if we can log in as the administrator user. Let's make it a little bigger. The user should be administrator and I'm gonna supply the hash. Fingers crossed. Amazing. We are inside the domain controller as the administrator user. We have its PowerShell. Let's execute the UMI. Yep, we are the administrator. Now we can perform some actual damage since we don't have any restrictions on executing any commands. First of all, let's see what kind of users are residing inside this uh, DC. Okay, that's the Deval user. That's the administrator user. Now I still don't know the credentials of the administrator, but I can just change it from here. Let's anything that complies with Windows password policy, ABC at 1234 should work. And let's just do a group policy update real quick to avoid any synchronization errors. Otherwise, we might have to wait for a long time. This just does it in an instant. Shouldn't take too long. And okay, done. Now we know the credentials of the administrator user. Now, since this is a Windows environment, I think that a graphical interface would be a better approach. Let's enable RDP here, and also let's bypass it through the firewall. Okay, this should take a few minutes. Okay, not a few minutes, a few seconds. Okay, that's done. Now we know the credentials of the administrator. We have enabled remote desktop. Let's now connect to the remote desktop. Let's make a profile here. I'm gonna use Remina again. I'll just call it Aqua Sentinel DC. Let's apply the IP address, the username, and the password that we just made. Okay, should be ABC at 1234. Okay. Now, what I really like about this tool is you can set up certain resolutions, the quality. I'm just gonna use the client resolution, color depth is fine. And for demonstration, I'm gonna select the best quality. Okay, let's save and connect. Amazing. We have hijacked AquaSentinel's domain controller. We are officially inside the domain controller as the administrator. Now we do have full control over it. We can perform any kind of damage that we want. Now, since it's like a nested remote connection, my keyboard's baud rate is going to be super bad. So I'm just gonna use on-screen keyboard here. Okay, I can run the CMD as administrator. Actually, let's do one thing. First of all, let's see what users are residing inside the Active Directory environment. Okay, so for enterprise, you have the Said user and some other user here. Let's check the field control network. That's our main goal here. Okay, that's local admin, the username, the description says plant admin. Okay, now I know the OT admin's username. I still don't know where the OT network is. Let's see if this DC knows. I'm just gonna run the netstat command here to discover the processes which are running on this DC at the moment. Oh, look at that. Okay, so we found port 4840, which is the port for OPC UA. Now, this is another protocol which you would expect to find in an operational technology environment. So, there's a high chance this 192.168.1.0 network is actually running an OT environment. Uh, so, let's see if we can find something else. I'm just gonna run another nmap on it. to see what other devices are residing inside this 192.168.1.0 network. Okay, that's done. Let's scroll up, see what we have found. Okay, so for this 1.26 device, we found port 20,000 open. Now, this is actually the port for DNP3, Distributed Network Protocol 3, which is a protocol which is used for communication in SCADA environments. And looks like we have a remote access device here. A remote desktop is enabled on here. And we also have some web pages running on 168 and 174. Let's investigate the web pages. So for this 168 web page, this is a Allen Bradley remote IO. You can see 173.4 ANTC. And for communications, it's actually receiving, transmitting to 174, which should be our PLC. And this 174 looks like an Allen Bradley PLC, even if you check the connections. It's receiving information from 168 remote IO and transmitting it to 197, which is our HMI. Now, to connect through the remote access device, I still don't know the credentials. So what I did, through the Evil WinRM, I changed the credentials of local admin to just bad Allen1234, since they love Allen Bradley so much. Let's see if we can now connect to the remote access device through here. I'm just gonna name it remote access device. Let's apply the IP address. The username should be local admin. And I just changed the password to bad Allen1234. Okay, the client resolution. Let's just select the quality to good. Should be okay. Save and connect. Okay, we are inside the remote access device. I have already installed Studio 5000 here. And since this device can reach the PLC, let's just upload the program that they're running on the PLC to see what they're doing. Okay, upload. This is actually uploading from the PLC. I just want to see what how their ladder logic or whatever code that they're using is running. Okay, that's a ladder logic. So they're running a PID block here, and okay, they have a set point of 200, and looks like the set point convert, gain convert. What they're doing here is they're trying to tune these parameters through a different device, probably through their HMI. Now, I don't want them to be able to do any of that. My main goal is to overflow their tank and to not let them control anything through HMI. Now this is my own ladder logic code. I'm gonna set the set point to 300, and I've removed all of those move tags so they can't run anything. I'm just gonna download it to the PLC, and let's see what happens after we download it to the PLC. You can see I'm writing through here. Their tank is gonna get drained. The tank is empty now, their reservoir is on the point of exploding, it's up to the brim. Our poor pumps are struggling, they don't know what's going on. Now, let me show you a little magic trick when I click yes here.
So the level of the water is changing, and that
Yeah.
sort of attack that they're doing here.
So the set point was 200 before. It should have stopped at 200, but as you can see, it's continuing to rise. The levels continuing to rise. Now the alarm's ringing, the tank's overflown. As an operator, what would you do? You would run over to your HMI to quickly contain it. Now let's see what happens when we go to our HMI to tune it. Oh shit! It throws an error code from the PLC. Okay, I'm gonna change the set point 200. It's not letting me do it. Gain, let's make the gain 2. It's not letting me do anything, it just throws an error. It just throws that error code return from PLC. I can't do anything. There's panic all around, my tank's overflowing, the alarm's ringing, the level's now 300 and I can't do anything to stop it. My plant is gone.
Hello, my name is Saif and I'm a security analyst. I will explain you how the attack happened and how you can mitigate this kind of attacks. So if we look here, in our DMZ, the attacker first exploited the vulnerability that was SQL injection. So how we can mitigate it? We can review the code, we can find out that why it was able to inject the queries. We can change the code and then we can mitigate this part, and then the attacker had a backdoor access to our FTP server. What we can do, we can update our FTP server and keep track of it, so like regularly updating it. So that's how we can, first of all, clearly eliminate the vulnerabilities exist in our corporate network. Then we can add our IDS IPS system, which is Surikata. We can add this between our firewall and our corporate network. So what this will do, it will try to match the patterns. If it detects any anomalies in the network, it will block the traffic. Moreover, what we can do, we can put application control here. We can restrict certain ports. For example, the attacker was able to gain access via port 6200. We can block unnecessary ports. We can only allow certain ports. For example, for HTTPS 443, for FTP 21, and for DNS only 53. We can only allow these ports that are mapped through our virtual IPs. Then we can implement honeypot. The honeypot we are using here is a KF sensor. It is IDS honeypot. It will simulate fake services such as SSH, FTP, and Telnet. These services are there to collect threat intelligence. We can learn about what attacker is trying to do, what their motive is, and what methods they are using to hack into our system. So after securing this part, we can come back to our firewall. So we saw that there was a WinRM service running when the attacker scanned our network. What we can do, we can restrict the traffic flow. So first of all, we divided our network into smaller zones. So now we can control the traffic efficiently. We can block the WinRM connection coming from DMZ to here. We should only enable WinRM connection within this enterprise zone, not coming from anywhere outside. So this is how we can eliminate that vulnerability. Let's move on to our control part. So we saw that the hacker was able to access from FTP to our remote access device. So that happened because in industrial environment, it is common to have an RDP enabled device, because operators and engineers like to have access to the software from anywhere. So what we can do, we can divide this network into multiple zones. We can add another honeypot and we can separate our field control network. So by doing this, we can control how network is flowing through our network. So for example, RDP device never needs connection to our PLCs. In our previous attack, we saw that RDP was connected to the same subnet as this PLC is. So by separating them, we are eliminating that risk as well. Once again, application control is important to only allow certain types of services. The honeypot we are running here is a Conpot. This is an ICS honeypot. It also simulates services like BACnet, FTP, and Modbus. So this is also very good tool we can put in our network to attract the attackers. The reason why we have two different honeypots, because we have two different FortiGate firewalls, and those firewalls have separate connectivity, as my previous teammate Jahin mentioned. Those FortiGate firewalls have different domain. So for example, if the attacker search AquaSentinel.com, it is very likely that it will come across ics.aquasentinel.com. So when the attacker scans that network, it will scan the honeypot and will interact with honeypot instead of messing around with our other network. Yes, and if you see these small icons, these are EDR agents. These are endpoint detection and response. We are using Wazoo SIEM, which is hosted on cloud, to collect logs across the network. So we have deployed our agents across our Linux servers, our Windows system, and in our RDP device, and as well on our honeypot. Our FortiGate are also sending logs to our SIEM server, which is Wazoo. Wazoo is a very good SIEM EDR tool that allows us to collect logs from any devices. And so what Wazoo does is when it detects any anomalies in network and it detects potential threat, it will quarantine those devices to prevent escalating the attack. So that's all.
Thank you so much.